Hello everyone, welcome back. Today I'll be doing the linear regression project with the vehicle sales data. The GitHub link is in the description below. You can download it. Once you download it, let's open the follow along notebook. First, we need to import all the necessary functions. We'll be using 3 in this project. The first is pandas. We'll be using that to read our dataset. And then the seaborn is used to draw the correlation heat map. Matplotlib is for the scatter plot and line plot. So let's first load the data. Let's take a look at our data. We have a lot of attributes. We have the car name, the year, the selling price, the present price, kilometers driven, and etc. So the goal in this project is to predict the selling price using linear regression. So we need to choose the attributes that has the highest correlation. So what is correlation? Correlation is a measure of linear relationship between two attributes. So let's use the seaborn heat map library to see the correlation. We see in this heat map here, the attributes always has a correlation of 1 with itself. So that's why we see 1s in the diagonal. And if we take a closer look at the selling price, we see that the present price had the highest correlation. So we'll be using the present price to predict the selling price. And that makes sense, because the higher the buying price, the higher the selling price. Next, let's actually draw the scatter plot between the selling price and the present price. And we see in the x-axis we have the present price, and the y-axis we have the selling price, and we do see a linear relationship between them. And it's positive and it's very strong. In contrast, let's take a look at the kilometers driven, which has the smallest correlation in magnitude with the selling price. So if we draw the scatter plot, we see basically a rectangular box right here, and there's no linear relationship between them. Next, let's write out the necessary functions to build our model. First, let's define what is our x. X is the present price, y is the selling price. And we need to define 3 functions: the mean, the variance, and then covariance. If you remember from the last video, we need to have those 3 statistical functions to calculate our A star and B star. So let's actually calculate the mean of x and y, the variance of x and y, and the covariance between x and y. So let's fill in the blanks here. Mean x, mean y gonna be equal to mean x and mean y. So let's call those functions. And the variance of x and y, we need to call the variance function and pass in the necessary parameters. So let's go ahead and do that. So variance of y, and then we need to pass in the mean of y as well. And next, the covariance. The covariance function. So mean x, y, and mean y. And if we go ahead and run that functions, we do see our x means, y means, x variance, y variance, and covariance. So that's perfect. Now let's actually fit our model. Our model, we need to calculate the coefficients, or we call it A star and B star. From the previous video, we noticed that we need to find B star first. So A star is actually depends on B star. So what is B star equal to? It is equal to the covariance of x and y, right? So we need to call the function. We need to pass in the mean x and mean y. So this will give us a covariance, and we need to divide the covariance by the variance of x. So variance of x. Alright, that's our B star. For the A star, we take the mean of y, subtract B star, times the x min. Alright, let's run that. It gave us the A star, which is equal to 0.7, and B star is equal to about 0.5. Okay. Alright, next, let's visualize our result. So I made an empty list called predictions, and I loop through each x value, and I'm gonna make a prediction on what the selling price will be, and then append it to the predictions, and then we're gonna draw a line graph together with the ground truth data as a scatter plot. So let's first make our predictions. For each value, we need to have the A star plus B star times the x val. This will be our predictions, and we'll append it. And actually, let's look at the plot. Alright, so this straight line here will be our best fit line. One way to improve this line is by removing these outliers here. If we remove these outliers, this line will be more like this way. Alright, but I'll leave this for you guys to figure it out. This is what the linear regression is. Hope you like this video. If you have learned something from this video, please hit the like button, subscribe to the channel, and please turn on the notification. I'll be releasing more videos about machine learning and data science. See you guys in the next video.